Welcome back to computer science classes. Session 37, Relational Algebra and Set Theory, Additional Operators, Aggregate and Functions, which comes under Chapter 6, Relation Data Model and Relational Algebra. So here, what is meant by relation model? So actually we have in this relation model and relation algebra, so we learn about relation data model and relation algebra. So here the part 1 gives some information related to terminologies about relation like domain, degree, coordinality, tuple and column, etc. Constraints are relations like domain, key, entity, referential integrity, etc. Operations and relations like insertion, deletion and updation. So this is called as relation model. So what is meant by relation algebra? This is very important here. So the definition of relation algebra is: the relation algebra is a procedural query language. The relation algebra is a procedural query language. It consists of a set of operations that take one or more relations as input and produces a new relation as an output. So once again, what is meant by relation algebra means: the relation algebra is a procedural query language. It consists of a set of operations that take one or more two relations as input and produces a new relation as output. Relational algebra has two types of operator. It has two types of operator. So particularly one is called as unary relation operator. Second one is binary relation operator. Unary relation operator and binary relation operators. So relation algebra and set theory. So because the Cartesian product operation is also there, it allows combining information from two relations. It is denoted as Rx, where R and R relations. So here first unary relation operation. So unary relation operation. So unary relation, these kind of operations can be worked only on a single table. So it has select operation, project operation. So a selection operation, it is used to identify a set of tuples which is a part of relation and to extract only these tuples out. The select operation selects tuples that satisfy a given predict or condition. It is unary operation defined on a single relation. It has denoted as symbol, that is one symbol is there, that is called as conditional symbol. And project operation, it used to return the argument, its argument relation with certain attributes left out. So it is denoted by symbol. Okay, like we have so many operations like binary operations also there. So binary operations means these kind of operations requires minimum two tables or sets. Set operations combine the results of two queries into a single result. Queries contains set relations, set operations are called compound queries. So in particularly, set operations combine the results of two queries into a single result. Queries contain set operation are called compound queries. So particular once again, so in relation algebra, so we have two types of operator. One is called unary relation operations and the second one is called binary relation operations. Unary relations operations means these kind of operations can be worked only on a single table. So these operations has select operations and project operations. The select operation, it is used to identify a set of tuples which is a part of relation and to extract only these tuples out. The select operation select tuples that satisfy a given predict or condition. It is a unary operation defined on a single relation. It is denoted as condition operator. We have a simple syntax here: condition, table name. Suppose if we are taking any example, I will take one example per book table. Account number is there, year of publication is there, title is there. For example, account number 734216, year of publication 1982. So title is algorithm design. Second one 237235, like that, 1995, database system. So here that is called as the simple table. So example, select from the relation book all the books whose account is greater than or equal to 56782. So then we can use the syntax, the condition operator, account number greater than or equal to 56782, bracket book is there. So this is the best example to select operation. The second one is called as project operation. It is used to returns its argument relation with certain attributes left out. It is a unary operation defined in a single relation. It is denoted as pi symbol. Syntax pi, column 1, column 2, up to column n, table name. Example 1, list all the title and account number of the book, relation by account number, title, book. So I'll take example 2 here. The table E for employee, serial number or NR, name, salary. 1 John 100, 5 Sarah 300, 7 Raju 100, like salary is there. So totally in selection operator the tables is the same table E for employee as above, because each and every employee has the particular salary, and the relational algebra size shows the condition salary less than 200 of E, and sometimes the condition shows condition salary less than 200 and NR greater than or equal to E, question mark or E. So that is called as selection. In projection, selection on salary from, like if you want to select any salary, when the result is only for salary 100 or 300, relational algebra that shows pi salary of E. Select NR salary from E, NR salary, so then pi NR salary of E, that is called as 2. The second one is called as binary operations. These kind of operations requires minimum 2 tables or sets. 2 tables or sets. Set operations combine the results of 2 queries into a single result. Set operators combine the result of 2 queries into a single result. Okay, queries contain a set of operators are called compound queries. Set operations combine the results of 2 queries into a single binary result. Queries contain set operators are called compound queries. So okay, set operators in SQL. For example, I am taking set operators. What is meant by set operators? What are the set operators which are available in relational algebra? Set operations which require requirements. For set of operations to function correctly, the relation R and S must be union compatible. 2 relations are union compatible if they have the same number of attributes. The domain of each attribute in column order is the same in both R and S. The domain of each attribute in column or order is the same in both R and S. Because the 2 relations are union compatible if they have same number of attributes. Second one, the domain of each attribute in column order is the same in both R and S. Okay, that is called as set operators. Is the set operators are in SQL are, one is called union. So what is meant by union here? Second one, intersect. Third one, minus. Fourth one, Cartesian product. So how many set operations are there? In particularly binary, it has some set operations. In set operations, because it has requirements for set operation to function correctly, the relation R and S must be union compatible. 2 relations are union compatible. Okay, union is there, intersect is there, minus is there, Cartesian product. So what is meant by union? Union returns all distinct or unique. Union returns all distinct or unique tuples selected by both the queries. Union returns all distinct or unique tuples selected by both the queries. It is used when we need some attributes that appear in either or both of the 2 relations. It is used when we need some attributes that appear in either or both of the two relations. It is represented by two circles which are with shading. Two circles are joined each other because that is called as union. So actually the union is always denoted as U, the symbol of U. It is always denoted the symbol of U. Okay, that is called as union. Okay, fine. You see, one example is there on the table here, and the union operator select only unique values by default. That's all. Union operator select the unique values of values by default. Okay, fine. So I will take one simple example here. Table R, and I have two tables. One is called R and second one is called S. Table R has A, B, D, F, E. It includes the values 1, 2, 3, 4, 5. Okay, table values 1, 2, 3, 4, 5. And table B. Table B is nothing but S. It has A, C, D, E. It includes the values 1, 2, 3, 4. A, C, D, E, that it includes 1, 2, 3, 4. Okay, fine. A, C, D, E, it includes 1, 2, 3, 4. So what is the union here? So R union S. This is the result. R union S. That is called as result. Here both the R and S tables names and values are combined to each other. You see, A, B, C, D, E, F, E. Means first one is for A, B, D, A, B, C, D, E, F. Totally all the values. So suppose here you see the E in R table, E that contains 5, and here S table that contains 4. So both are combined to each other. A is 1, B is equal to, C is equal to, D is equal to 3, E is equal to 5, F is equal to 4. But once again S, E contains E, but the value is quite different. That's why we are taking another ones. E is equal to 4. That is called as union. That's called union. Okay, fine. So once again, what is meant by union? So union results all distinct unique tuples selected by both the queries. It is used when we need some attributes that appear in either or both of the two relations. It is represented by two circles are combined to each other with shading. So it is denoted as U symbol. The union operator selects only unique values of by default. And I will taking two tables here, R and S. R inputs A, B, D, F, E and values 1, 2, 3, 4, 5. And S that includes A, C, D, E 1, 2, 3, 4. Or union S, that is called as result. A is equal to 1, B is equal to 2, C is equal to 2, D is equal to 3, E is equal to 5, F is equal to 4, and finally E is equal to 4, because the E displays both the tables R and S union. Suppose I am taking one simple syntax here. Select column names from table 1, union select column names from table 2. That's all. Select column names from table 1, union select column names from table 2. That is called as the best syntax of union. Okay, fine. That is called as best syntax, means select column names from table 1, union select column names from table 2. So second one is called intersection. Second operation is called intersection. What is meant by intersection? What is the use of intersection here? Okay, fine. Intersection, this operation returns only those rows which are common in both the queries. So this is a simple meaning. This operation returns only those rows which are common in both the queries. Which are the common values, which are the common names, which are both the tables or queries. Okay, fine. Okay, it finds tuples both the relations. A tuple is nothing but row. What is meant by tuple here? Each a single entry in a table is called tuple, is nothing but row. Okay, it's nothing but record. We are also called as record. Okay, the operation returns only those rows which are common in both the queries. It is finds tuples in both the relations. It is denoted as ulta U symbol. You can, so U is going to ulta, that is called as U symbol. So it is represented by, so two circles are combined to each other, but in between one joining part is there, joining part is going to shade it, that is called as intersection. Okay, I will take one simple example here. R and S tables are there. R includes A is equal to 1, B is equal to 2, D is equal to 3, F is equal to 4, E is equal to 5. So S table includes A is equal to 1, C is equal to 2, D is equal to 3, E is equal to 4. So then R intersection S. R intersection S means, so then we can take A and D, because both the columns we include same values, that is called A is equal to 1, A is equal to 1, and D is equal to 3, D is equal to 3, that is called as intersection. So what is meant by difference? So it's nothing but minus or difference. So the operation returns only those rows that distinct in the first table but not present in the second table. That is in first table, the operation returns only those rows that are distinct in first table but not present in second table. So like it finds tuples in the rows relation, but in the order it is denoted with minus symbol. It is represented by two circles are combined to each other, but only one circle is going to shaded with not joining position. So you see the difference that will be shows like that. So A is equal to 1, B is equal to 2, D is equal to 3, F is equal to 4, E is equal to 5. Yes, A is equal to 1, C is equal to 2, D is equal to 3, E is equal to 4. So S difference S here, R difference S is the first one, B is equal to, F is equal to 4. So both the table, B is not there, okay, fine. F is not there, fine. E is not there equally. R difference S. S difference R, C. Okay, C is not there. And then E, sometimes E here 5, here 4. That's why E is equal to 4. So one syntax is there, select column from the table, difference or minus, select column names from table 2. That is called as difference or minus. So next, what is Cartesian product? So Cartesian product, it is also an operator which works on two sets. It's sometimes called the cross product or cross join. Cartesian product is also an operator which works on two sets. It is sometimes called the cross product or cross join, because it allows combining information from two relations. It is denoted as R, X, S, where R and S are relation. R and S are relations. Okay. Totally, it is an operator which works on two sets. It is sometimes called the cross join or cross join, cross product or cross join. So example is there, that is called as R and S. A is equal to 1, B is equal to 2, D is equal to 3, F is equal to 4, E is equal to 5, A is equal to 1, C is equal to 2, D is equal to 3, E is equal to 4, S, R cross S. So A value will be prints, B value prints, D value prints, and right side A, C, D, E, A, C, D, E, A, C, D, E, that prints the particular values, and the next table F, 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 E, the values of 4, 4, 4, and then 5, 5. A is equal to 1, C is equal to 2, D is equal to 3, E is equal to 4, A is equal to 1, C is equal to 2, D is equal to 3, then E is equal to 4. That is called as Cartesian product. So totally, set operations requirement each for set operations to function correctly, the relation R and S must be union compatible. Two relations are commonly uniquely compatible with, they have same number of attributes. The domain of each attribute column order is the same as both of us, the R and R. So and finally we have notations also. So the operations are used in relational algebra. They have their own symbols, because each and every have symbols. So each and every symbols that are particularly represent the operation: projection operation symbol, selection operation, renaming operation, union operation, insertion operation, assignment operation, Cartesian product operation, join operation, left outer join, right outer join operation symbol, full outer join symbol, and semi join symbol. So the next point is addition operation and relational algebra, aggregate functions and grouping. What is meant by aggregate functions? So here aggregate functions means the first type of request that cannot be expressed in basic relation algebra is to specify mathematical aggregation functions on collection. Aggregation functions on collection. Okay, so that is called as aggregation functions on collection. The type of request that cannot be expressed in the basic relational algebra is to specify mathematical aggregate function on collection of values from the database. That is called aggregation function. So what is meant by grouping? Another common type of request involving grouping the tuples in a relation by the values of some of their attributes and then applying an aggregate function independently to each group. That is called as grouping. So here aggregate function, additional relation operation, we have two aggregate function and grouping. Aggregate functions means what? The first type of request that cannot be expressed in the basic relation algebra is to specify mathematical aggregate functions on collection of values from the database. So second one is called, another common type of request involves grouping the tables tuples in a relation by the values of some their attributes and then applying an aggregate function independently to each group. That is called as grouping. So in this session we understand so many information related to relational algebra, because in relational algebra so many operations are there, unary operations are there, and union operation is there, intersection operation is there, difference operation is there, Cartesian product, notations, addition relation operator, aggregate function and grouping. Each and every one has the particular with the example we can give all the information related to relation algebra operation. Okay, thank you. I will see in next session. Thank you.